Hello, this lecture is about the economics of product development. It deals with building a financial model of the development project. This is really about how do we make sure the product development project makes money, how to make a business case for your product or project. The method we will use is based on the net present value (NPV) calculations, which is the time value of money or discounting of cash flows. We will go through an example to show what inputs are needed to run the analysis and what do we do with the outputs. Economic calculations can take place at various points in the development process, particularly at phase gates, where the project has to pass through successfully before advancing to the next phase. You can think of this as go, no-go decision. So the team presents some financial analysis, and if it does not seem profitable, then you may not pass through. So you may not even launch a development project after this gate right here, right after planning, if it does not look very promising, the project. We may do the same after concept development and after detailed design and after testing and refinement, right before ramp up and production. This one, right before ramp up production, can also say, the project is not profitable and we will not move forward with the project. Or we may say that we have invested a lot of money so far on the project, but it does not look profitable at this point, or we may actually lose money on it, but we still want to move forward with the project because we can learn a lot from this project. So for learning purposes, you can also go ahead. It's not a purely financial decision. That's what I'm trying to say. But still I want to know how much I'm paying for this learning and experience. So this analysis serves for both purposes, I guess. Then these red squares over here, represent many points during the development process where various types of sensitivity and trade-off analysis occur. To support the ongoing decisions of the team, there are various kinds of financial analysis that may help them. For example, this may support the design for manufacturing analysis that we've done in the previous lecture. For example, we're going to spend a bit more money on, let's say, tooling, but we are going to reduce development cost. Is it worth it? We are going to spend more on this to save a little bit on that. Is it worth it? And let's quantify this by doing calculations. So that's one of the many detailed decisions that we want to support by doing this kind of analysis. This is a depiction of the cumulative cash flows over time. There are several of them. The outflow is the dashed curve, blue one, which is the investment in product development and production ramp-up, such as tooling. At some point in time, we stop investing and the curve flattens out because it's cumulative. This curve is reflected on the positive side with the minus sign. So we can easily depict crossovers. The other two curves, the red one, depicts the sales. At some time, we start selling the product, right about here, around where we stop development. Sales start slow, and maybe they will pick up and accelerate as the product matures, and then slows down as it becomes mature and the market saturates. The green curve is when we take our sales revenues and subtract out the cost. So sales revenues minus operating cost give us the operating profit, which is the green curve. Those ongoing costs include production cost, marketing cost, and whatever cost you incur during operation. And what we have left is operating profit or net revenue. Okay, down here we got 3 time scales: development time, payback time, and break-even time, or time to profit, time to money. Development time, that's from the beginning of development until we are ready to make money. Just having a short development time does not mean we have a great product, and does not mean we will be able to pay it back. So we might also look at payback time here, which is from the time we make our first sale until from the time we make our first sale until we make our first profitable shipment. That is right here. You start making actually money, because the sales you make before this point, you are actually paying for your investment still. The sum of these two times is what we call the break-even time. The break-even time is a pretty good metric for a measure of project success if you want a time-based metric. HP uses this, and they call it time to money, TTM. It's also used for tracking the time to make money on a project. So time to money is a reasonable metric to measure success of the project for a couple of reasons. First of all, the more you spend on development, the slower it is, larger than we have a larger TTM, or break-even time. That is, if the blue curve is bigger, it goes down further or up further. That means it takes longer to pay back the investment. If we have a lesser quality product, for example, then we will have slower sales, which also increases TTM. So slower sales increases TTM also. So in one single time-based metric, this handles pretty well. As I said, the project financial analysis may also be called business case analysis or product economics. Net present value is the most used way to do so, and it is just a way to add up all these cash flows in terms of today's money, i.e., that is, with some discounting. First, we start building a base case model, and this provides a nominal net present value. This number may be informative, but based on assumptions that you have made, and you would like to see how sensitive this number is to the assumptions made. So we want to perform sensitivity and trade-off analysis. Then we're left out with these hard to quantify factors that we cannot put into these financial models, but these actually do influence our decision making, such as learning, experience for future projects, or even social value. We'll talk about how to handle these later. Net present value calculations are pretty straightforward. We sum up the cash flows over all periods. But before summing up, we discount each of them by some discount or interest rate. Usually this is between 10 and 20% for most product development projects. N here is the time frame the project is considered, and usually we use 5 to 7 years. For example, what is $1,000 that you collect next year worth now? That is in today's dollars. So basically, it's one period, 1 year, and you have $1,000 divided by 1 plus, let's take the interest to be the hurdle rate or the discount rate to be 10%, then 1 plus 0.1, it's 1.1 to the power 1. $1,000 divided by 1.1, that will give you 910. So $1,000 a year later in today's money is 910, so it should be less than, of course, the future amount of money. Then, of course, if we have 2 years later, then this I will be 2. Okay, you have $1,000 divided by 1 plus 1 to the power 2, and that'll give you the what is $1,000 2 years later worth now in today's money. These are all the inputs that we need in order to develop a financial model. For each cost, we need to assign a time period for it. That is, when do we incur that cost? When does it start? When does it end? Costs generally include development, testing, tooling, ramp up, marketing, and so on. You can get as detailed as you want, obviously. Of course, each of these costs also is a sum of a bunch of line items. Sales are when does it start and when does it end and what is the shape of the sales growth. And we need to know that as an input. A unit production cost and revenues are also inputs. Finally, a discount rate, interest rate, hurdle rate, all the same, which I said is usually between 10 and 20% for most product development projects. What we will do next is run through an example for which we need to assign all these numbers and will allow us to talk about these numbers in a bit more details. The example that we will work on in this lecture is a hammer example. This is a Stanley hammer designed in 1995 by a company called Product Genesis and designed it for Stanley tools. Product Genesis is just a contract product development firm that did the design. So one question that comes to mind, why did Stanley outsource the design to Genesis? There are several reasons for that. One possibility is to get fresh ideas. So they want to hire an outside company to do the design for them, or they just don't have enough development capacity to execute this project, so they hire an extra resource. So what happens here is usually they asked Product Genesis to do the conceptual design and the industrial design, but usually they did the detailed design. Stanley did the detailed design and process design. And that's indeed what happened with Stanley. So this hammer is a contractor grade. It means it's made for professionals. Has a composite graphite composite shaft. This shaft is graphite composite and has a soft rubber grip right here and sells for about $20. So this is the product we are going to investigate. We will estimate what are the costs for this product, what is the development cost, ramp-up cost, marketing cost, and so on, to see what is the business case for this product or project. The way we are going to do this is let's look at these costs one line item at a time and we'll make some estimates. So here's our list. Okay, so let's imagine what is the project like and try to estimate what might the cost be. So I'm gonna make some guesses and then support them with some logic or some searches I've done on this project. Let's start first with the development cost and timing. How long it might take to develop that product and what it might cost. I'll say 4 months for a 10-person team. Here material cost is low and we are mostly paying for the people, industrial design time and marketing research. Really what happened, Genesis charged $20,000 for 2 months of development work, mainly on concept design and the design of the handle. It did not include detailed design and manufacturing engineering. This was done by Stanley. They spent around $50,000 doing detailed design and another $50,000 doing manufacturing engineering or production engineering. This whole process took 9 months. So we have in total then $120,000 for 9 months. Now we move on into testing cost and timing. What kind of testing do you suppose is needed here for this type of product, and when would that take place? So basically, I'll say that you give a bunch of hammers to a bunch of contractors and see how will it perform and how well these hammers are received. Let's say we make 1,000 hammers and distribute them to those contractors. So that would cost around, let's say, $100,000 to make those 1,000 hammers, and took about 1 year. Actually, this year is overlapped partially, or could be overlapped partially with the earlier 9 months here. So it doesn't have to be sequential, as we will see in the spreadsheet that goes along, the spreadsheet financial model that goes along with this slide. Tooling cost. Oh, okay, we're not done. Before tooling cost, then what would be the total cost? It would be $100,000 over 1 year, which is overlapped with this 9 months. The tooling cost, now we need to estimate the production processes involved so we can estimate tooling cost. We need tooling to make the grip, tooling to make the shaft. Rubber handle is injection molding. The shaft is also injection molding. Some machining is required for shaping and polishing the handle. Each mold we need is in the order of tens of thousands of dollars. Let's say $20,000, depending on the complexity of the mold. Stanley paid $200,000 for tooling, and it took 6 months to obtain that tooling. They bought injection molds that have 2 to 4 cavity molds, so they paid more money, but they will be able to do multiple shots. These molds are also insert molds, which makes them a bit more expensive. Insert molds are for the grip. You know, they insert the shaft into the mold and they flow in the material. So total tooling cost of $200,000 over 6 months period. Next is the ramp-up cost and timing. What is involved in ramp-up and how long does it take? We would make a few at first to do some more tooling, to do some more testing, internal and market testing. So we also make lots of scrap in the initial production phase before we remove all the bugs and the production problems from the process and the production line. We also do some learning as we start and we accumulate some of this learning and experience. A ramp-up can also be expensive if you need to forego the production of an existing profitable product in order to make room for the new product due to capacity constraints if they share the same process steps. For this project, it took Stanley $50,000 for ramping up in 3 months' time. The next line item we're going to look at is marketing support and marketing support costs and timing. How do you suppose Stanley will go about launching this product and making sure that we have great sales? They have to do advertisement in magazines, TVs, TV ads, design displays for the promotional period for some time, flyers, brochures, trade shows, etc. All of these are good ideas. So what does it cost to do all of them or some of this? Say one marketing professional is full-time for 1 year, will cost around $100,000 to $150,000. plus some expenses. So 250K for 2 years plus 80K for 4 years. That's how much it did cost Stanley to do the marketing and support. Sales volume and lifetime. So those are an order of magnitude estimates. 2,000 units per year over 5 years. And we have the unit cost. Target costing is $20 you pay. That's the final price. So if the final price you're selling to the customer is $20, $12 for Home Depot, let's say, which is the distributor with the 40% markup, or the retailer. So basically, let's assume there's one echelon, and then basically after that, $6 Stanley's cost. So $4 per unit plus $2 per unit overhead, and that comes up to $6. Discount rate, which makes actually the unit revenue is $12. If discount rate, 10% per year. But what is this, and where does it come from? This is how we discount future money back to today's dollars, time value of money. It is about other opportunities for investment. If I didn't invest in that hammer, what do I do with the money? That's basically how the discount rate is calculated. There are some adjustments for risk also. If there's a high risk in this project, then the discount rate will be higher. We may not actually have the demand we hoped for. That this is a market risk, or the manufacturing cost we thought to be this number, and it turned out to be much higher, and that's a technical risk. So we need to reflect some of that risk by discounting the project at a higher rate. Okay, so we expect higher returns for high-risk projects. Okay, usually this number is provided by the accounting department, and the development team does not worry much about where this number comes from. So these are all the inputs which I have, which I need to run or to build the financial analysis model, or the financial model, which I'm going to show you in the Excel sheet that comes next. So this is a simple financial model that goes along with the hammer example in the previous slide, and it's found on Moodle. So you can download this file, this Excel file, on Moodle, and you can obviously use it and tailor it specifically for your own project. And as I said earlier, those line items that are high-level line items can be detailed as much as possible as you want, but these are the basic line items that are found in the previous slide. For instance, here is a list of the various costs inputs to the financial model that we talked about. There's the development cost here, testing cost, tooling cost, marketing cost, and several other quantities and costs. and you have also some of the production cost, unit sales, unit price, production cost. That's unit production cost actually, and so those are the quantities that we have talked about. You have also here a timeline that goes from one through whatever at the end, but these are in terms of quarters. So each 1 year is defined by 4 quarters. Okay, so that's how this Excel sheet is built. Then 5 years will be 4 quarters times 5 years will be 20 of these quarters, if you need to know. But anyway, so this Excel sheet is built such that you don't need to do anything on this part of the Excel sheet. It just displays whatever input you have, and the input is actually displayed right here. And for instance, the development cost, and the first time you start incurring the development cost is at quarter 1, and it ends in quarter 3 inclusive, obviously. So if you recall, the development cost in the previous slide was estimated to be $120,000 for a 9 months period. The 9 months period means 3 quarters, so and that's why I start in quarter 1 and end in quarter 3. And here the burn rate, that means how fast I spent I spend those $120,000, and I'm gonna assume that I'm gonna spend them or burn them equally over the 3 quarters, and that's why I see here the minus 40 for each quarter. So minus 40 in quarter 1, minus 40 in quarter 2, and minus 40 in quarter 3. And minus because obviously I am not making money, but I am actually spending money. So it's an outflow. Obviously the others are the same, and here you have the testing cost, and the previous slide shows that the testing cost was for those 1,000 hammers that were distributed to contractors. It was costing $100,000 over a 1 year period. That means and it was overlapped. If you recall, I mentioned that that testing cost you incurred was overlapped with the development cost that you incur. So that means, and I can see that here, that it's actually also starts in quarter 1 and ends in quarter 4. So it's overlapped with the earlier development cost. And again, the $100,000 is burned equally on those 4 quarters. So the $100,000 is $25,000 per quarter, and thus you see the minus is for actually you're paying the money. That means you're not making money, but you're paying. So you write down basically all of these costs as you incur them, and as we agreed on the previous slide. So tooling cost, it's only incurred over 6 months period, over quarters 4 and 5, as you see here, and it was $250,000, which was split evenly over 2 quarters. So minus 125 in each quarter. Similarly, the marketing cost was 250 for 6 months, and you incur it minus 125 in quarter 4 and minus 125 in quarter 5. If you recall, also that was the $80,000 per year for marketing support. Actually, those was the $80,000, and that goes over 2 years period, and that's why you see from quarter 5 to quarter 12, and that $80,000 is incurred, $20,000 per quarter, which adds up to $80,000 per year. So it's actually consistent, obviously, with the input data that we've seen in the previous slide. Unit sales, you sell it over 5 years period, starting at the end of development in quarter 5, so the beginning of year 2, and all the way until quarter 24, and you're selling 200,000 units per year, which means $50,000 per quarter. Again, $50,000. I'm sorry, 50,000 units, not $1,000. 50,000 units per quarter. So 50,000 units times 4 quarters is the 200,000 units per year. Unit price, again, you're gonna make revenues on the same time scale or period that you are selling the product. And you're selling it for 0.012. Obviously, it's positive because you're making money. That's cash inflow, and that's in thousands of dollars. So that's why it's 0.012. So it's really $12, but it's in thousands of dollars because all these other quantities are in thousands. Because this is originally was 40,000 at 40 only, and this is the discount rate. Okay, so once you have written all of these, then you can check the display area, and you can see that all these numbers are displayed for you, readily displayed for you. So there's no need to enter anything by hand here. So it's all displayed for you. And finally, you get the net present value for this project to be 3,451 in thousands of dollars. So it's 3.5 million almost. Okay, so if you press this as a base case, that means you want to anchor the calculations on this number, and then you want to do some sensitivity analysis now. So let's say and I do the sensitivity analysis here. Let's say that the development took 4 years instead of no, sorry, 4 quarters instead of 3 quarters. What would happen to my net present value? So I enter here 4, enter, and you can see that NPV reduced from 3451 to 3415 at a reduction of about 1%. So I'm going to undo this, and then if I want to increase that, the development actually cost instead of 40%, instead of $40,000 per quarter, it's an increase of 10%. So I put 10% here. I'm going to see also an increase of 10% would result in a reduction in MPV to 3440 instead of 3451, a reduction of 0.3%. And you can do some sensitivity here. Maybe this increase in development resulted in a decrease in cost. Let's say the decrease came to be unit production cost, and the decrease is cost is, let's say, 10%. No, that's an increase, minus 10%, enter. So this resulted, look, at actually, so you paid an extra 10% in development, and minus less 10% in production, unit production cost, resulted actually in improvement of MPV to 3886 instead of 3441. And that's how you can do many of these sensitivity and trade-off analysis. A little bit more here and a little bit less there. Is the overall result beneficial to me or not? Okay. Okay, some of the limitations of the quantitative analysis, the financial analysis model. Basically, the model focuses only on measurable quantities, and it does not include some softer quantities that cannot be measured, even though they may be important. Also, the model depends on, some assumptions that you make. These assumptions are a bit rough, especially at the early stages of development, which makes the estimates are rough too, the output. So we can consider also some qualitative factors which are not considered in the financial model. These qualitative factors could be creating knowledge in other projects, as I mentioned. So the project may not be terribly profitable, or actually you're losing money on this project. However, you still want to go ahead with it because it creates a lot of knowledge for you for future projects, and you learn a lot from it for future projects. So you want to go ahead with it. So ignoring the financial analysis. Also, we haven't included in this analysis, financial analysis, the competitive actions. What would your competition do, which may eat away sales from your own product? Actually, we haven't also considered cannibalization of existing products. But when you introduce a new product, you may be foregoing an existing profitable product, or actually, even if you're not stop producing it, you may be competing with your own products too, which we call cannibalization of your own products. So your sales estimates may not be exactly correct. Also, other things, the economic environment wasn't also integrated into this economic analysis model. Things like, maybe exchange rates, or unemployment rates, or things like that. that reflects the situation of the economic environment. Oh. The target costing idea is pretty straightforward and simple. That's how it works. First, find out how much the customer is willing to pay for your product, and that's setting the price, and that's you can get that from competitive products. Then you determine the profit margins required by each stage in the distribution channel, including yourself. Basically, you determine how much your own profit margin is going to be. And finally, you calculate the target cost based on the above two estimates. And the way we set this target cost then, or calculate it, by using this equation, which is in the book. So make sure you look at it in the book. It says that the target cost C equals to P, the price paid by the end customer P, multiplied by a series of multiplications, 1 minus MI being the margin of the ith stage. If there's one stage only, which is your distributor, then you'll have 1 minus your own margin, and then multiplied by 1 minus the margin of the distributor. And basically that's it, as simple as that. The cost plus method is exactly the reverse of the target cost approach. So the cost plus method is you figure out how much does it cost for you to produce this item or product, and then you slap on it or add to it some markup quantity. You know how much you're gonna make profit on it as a markup, and of course you include the various players in the distribution channel that way too.